One of the things that I have really picked up recently is NAD. So this is nicotinamide adenine dinucleotide. This is a really powerful compound. NAD is a classical coenzyme that mediates many redox reactions. They mediate many redox reactions, and just like a lot of things like antioxidants and other things in the body, NAD plus, the levels of NAD plus, they decline over time. So you're going to get declining levels of NAD, and these are really important because the decline, or I don't want to say deficits, but really like the reduction of NAD plus, they may cause defects in sort of nuclear and mitochondrial functions. And these can result in many like age-related or associated pathologies, not even just slumps in energy, but just a lot of different things, a lot of negative age-associated conditions and pathologies and issues. It's thought, and it has been studied fairly extensively. There's ongoing research showing that restoring NAD plus levels, restoring these through exercise as well as through supplementation with NAD precursors or intermediates, can dramatically ameliorate sort of age-associated functional defect. NAD may ultimately enhance the activity of sirtuins, and this is a family of enzymes. And one of the most extensively studied sirtuin is sirtuin 1 or SIRT1. And again, most extensively studied sirtuin, that's a member of the family, and it's dependent on NAD+. So in order to activate it, it's dependent upon that NAD+. What SIRT1 does is it regulates transcriptional activities of many different proteins engaged in the oxidative stress response. So this is really important. Like I talked about previously, the oxidative damage is associated with age-related issues and pathologies, and the skin, like the visible signs of aging related to oxidative stress, reactive oxygen species. So it's really important to know that these sirtuins that are dependent, SIRT1 in particular, is dependent on NAD. The sirtuin regulates those transcriptional activities of the proteins engaged in oxidative stress, or the response to oxidative stress. It also mediates the benefits of caloric restriction. And I think a lot of people talk about NAD as being a calorie restriction mimetic. So you can sort of take a precursor and intermediate of NAD like NMN, which I'll get into in a minute, that can help to sort of mimic the benefits of calorie restriction. There's a lot of research on calorie restriction suggesting that calorie restriction is associated with longer lifespan as well as just more vitality, more energy. And I think that related to just sort of the reduced burden of oxidative damage that occurs with food and metabolizing and digesting food. One of the things that also decreases over time is the cutaneous expression of SIRT1. So our skin also contains these sirtuins that help to, or may be implicated in the oxidative stress response, also declines with age. So that's another reason why maybe trying to potentially get those NAD levels up may be really important in helping to combat oxidative stress and oxidative damage in the skin. Other research suggests that SIRT1 expression is associated with total fibroblast amount. So its proliferative activity and may be responsible for the development of skin aging symptoms. So it's really important. I think it's really interesting to know that there is an association between SIRT1 expression and declines in SIRT1 expression with skin aging symptoms. And also, I think another important thing to mention is that SIRT1 can affect, at least according to the research, may affect UV-related skin changes. So there are several, like I mentioned, several factors associated with extrinsic aging. UV, or ultraviolet radiation, many researchers think that skin aging, UV is responsible for up to 90% of skin aging, the visible signs of skin aging. So there was a study looking at the sort of the epidermal expression, so the expression of SIRT1. These were samples obtained from healthy volunteers, and they showed that significantly reduced expression of SIRT1 in sun-exposed areas. They found that there was significantly reduced expression of that sirtuin in sun-exposed areas compared to non-exposed areas, showing that the sun drastically reduces SIRT1. Also, overexpression of SIRT1, the same study found that overexpression of SIRT1 is found to enhance oxidative stress resistance, and this was via the FOXO3 alpha promoted upregulation of the ROS enzyme, antioxidant superoxide dismutase, as well as catalase. The implications of that, or the suggested implications of that, is that the increased NAD increases the sirtuin 1, or basically ultimately they increase sirtuin 1, may upregulate superoxide dismutase and catalase, which again breaks down that hydrogen peroxide in the body, may help to protect the skin as well as maybe even the hair. But there's also experimental evidence that has shown considerably decreased SIRT1 in human dermal fibroblasts, exposed hydrogen peroxide. There we go with the H2O2 again. And there's some research out there to suggest that SIRT1 may also protect against pollution-associated aging. So pollutants in the environment are also associated with skin aging. So it's not just the sun, but it's also many other things in our environment that can be associated with that, with the visible signs of aging. Now I know that people like David Sinclair and Ben Greenfield, who I listen to regularly, I love their podcast, they talk about taking NAD precursors, and that's also mentioned in the literature as well, to increase NAD levels in the body, something like nicotinamide mononucleotide or NMN. And this is because NMN and these precursors, they're more easily absorbed than NAD.